Hi! In order to implement our first QEMU emulated PCI device, we need to know how to build QEMU from source, and that's what I'm going to show you in today's video. So let's start. First, let me navigate to the web page or the GitHub repository of QEMU, because here we need to copy the link to get the source. But when I scroll down a little bit, I can also find the build instructions. And for additional information, we can visit QEMU's wiki web page. And in here we see the required packets or the software we need to install to build QEMU. So in the Git, we need to install some libraries here, and we need the Ninja build system. So I've already installed these dependencies on my system, so I can skip this for now. And let's head back to the terminal and let's clone the repository. Okay, this will take a few seconds. So while this is cloning, maybe a small hint here. So these are the required packages, but if you want to have a full build with all the features which are available, you need to install a little bit more, and here you can find the packages you need to install. Yeah, so that's basically it. Hopefully our clone is done yet. No, not yet, so let me pause the video for a second so you don't have to wait for the clone to finish. Okay, cloning is done. So now let's navigate into the folder and let's create a build folder and cd into it. And now the next thing we have to do, we have to run configure. And first let's run configure with the help flag so we can see the help. So one very important thing is we have to specify a target list. So for which targets we want to build QEMU. So in our case, I will use ARM Linux users. So with this target, we can emulate user space programs with QEMU. Here are other architectures available, Arch64, somewhere we should have RISC-V for 32-bit and 64-bit. And these are all the user simulations, but if we want to emulate a whole system, we need this soft MMU target. So here we have ARM soft MMU for ARMv7 architecture, or Arch64 soft MMU for 64-bit, or ARMv8 architecture. So I will go with the following targets. Target list is ARM soft MMU, and I think I have to use an equal sign here, and then also ARM Linux user. So what else do we have here? Here we have some features. If you want to enable a feature, we have to write --enable minus and then the feature name. For example, if we want to have USB pass-through, so we can pass through a USB device, we need to enable libUSB, for example. Or another good target if you want to have network support is Slurp. So with Slurp you can add a network backend to QEMU, and you can use this, for example, if you want to forward your SSH port or any other port through your QEMU emulated systems. But I don't need this for now, so I will just use the target list ARM soft MMU and ARM Linux user. So now it will configure everything. It will check for the dependencies, and then you should be able to build it. Okay, now this is done. So if I type ls, you can see here a lot of folders have been created, and the most important thing here is this makefile. Over this makefile we can build QEMU. So let's do this. And as I have 12 threads available here on my CPU, I will run make -j12. So now the building process has started, and you can see it has to build about 3,000 targets. So I will pause the video for now, and I will be back when the build process has finished. Okay, so the build process has finished, and now if I take a look what has been built here, I can see I have a QEMU ARM here for emulating user space programs. And I also have a QEMU system ARM here, or which I can emulate a virtual Linux system. So let me show you how to do this. First, let's run QEMU ARM. And all I have to do here, I have to pass in the compiled program which is compiled for ARM architecture. And I will use here my BusyBox. So if I just run this, hey, I can see BusyBox has been started. So yeah. Or what I could also do, BusyBox echo hello world. And in this case it will print out hello world. Or another interesting thing would be uname -a to get the kernel. And here we can see, yeah, this is really ARM v7 architecture here. Cool, so emulating a user space program seems to work. Now let's try to emulate a compiled Linux system for ARM. So my machine will be vert, or with mhelp. Once again, I can see all the supported machines here, and these are all the machines supported by my build. I will use the vert target here, give it 256 megabytes of memory. My kernel binary can be found in Linux, Arch, ARM, boot, zimage, and my init are the rootfs cpiogc. My kernel's options are root is /dev/mem, and I want to use no graphics here. So let's start this, and now you can see my kernel is starting. Now the init process has run, and now BusyBox is up and running. If I type uname -r, you can see it's basically working. Cool. So that's how to build QEMU. And in my next video, if you take a look into hardware, MISC, you can see various drivers, and you can see a PCI test device here. So this is example implementation of a PCI test device. In the next video, I will show you how you can write your own custom PCI device, which will be emulated through QEMU. So I guess that's it for today. I hope you've enjoyed the video and learned something. In case you want to support my work, you can buy my coffee on buymeacoffee.com/jonas for Linux. So that's it for today. Thanks for watching, and goodbye.